Hi everyone, I hope I'm audible. Namaste. And just to give a context, I am founder and CEO of Gahan AI. At Gahan AI, we primarily work on developing autonomous driving technology, primarily focusing on replacing drivers where driving itself is life-threatening. Let's say, for example, our focus industries are mining and defense. In those cases, we develop a lot of hardware, sensor hardwares ourselves, and I am going to talk about today, I'll take 2 minutes to talk about only, so mostly when we talk about cybersecurity, often the examples are given on the lines of software. Today I'm going to talk about how hardware viruses exist. How many of you used to think that viruses are only on software? Probably many of you would have thought that. Have you ever faced a situation where suddenly you bought an electronic hardware and it has stopped working just after 2 or 3 days your warranty got expired? There exists a virus which actually works like a timer and it short circuits your hardware right after your warranty gets over. That exists, you can go and Google it, but not many people talk about it. Now that's probably a place where you are paying the least cost, which is just the cost of the hardware. But there often exist different types of hardware malware inside the electronic that you are using that can often transmit sensitive information from your device without even knowing. You will often see because of some updates, your hardware gets hot. But this hardware, those are software viruses, but these hardware viruses are very difficult to detect. That's where when we design our hardware, which are primarily, let's say, focusing on, like we design our own radar. These chips are coming in mostly from outside India. But the design that we do often have multiple components. And when there is a slight, and because we get it manufactured from companies often outside India, what happens when that gets shipped in, on our design, sometimes there can exist a hardware bug without our knowing it was not there in the main design. So and it is very difficult to find out because it's such a small circuitry within millions of components inside a PCB. Suddenly you have a very small tens of components which does not match to your original design, and your QA basically gets passed because it is often missed through human QAs. That's where we built in a lot of AI-based QA technologies. So rightly pointed out by Sir, on how it should be a co-pilot rather than just a human or just the AI-based software to do this kind of QA. The second thing that I want to talk about is, since we design a lot of these sensor hardware, when that sensor hardware is shipped and goes onto the field, at that point of time, also through external attacks, the sensor can be actually fooled. It's called as spoofing of sensors. Specifically, if you see how radar works, your radar basically transmits an electromagnetic wave, and that wave comes back with certain intensity, and from there we do decipher what kind of objects and how far they are, and so on and so forth. Suddenly, if you see that your radar is actually transmitting, but it is not getting any signal back, or the signal that is coming back through another device gets interfered, because of the advent of AI, now what has happened earlier, making those on-the-field changes used to be very difficult because human tuning takes time, and because these operates at light of speed, often those were not possible. But now with the advent of AI, what is happening is that the AI-based hacking hardwares are available which can actually very easily spoof, and because they can try out multiple combinations, they can actually spoof the sensors very easily. Now, how do we get around that? We need to be one step ahead as a designer, but often we fail in fields as well. There is no denying in that. But we want to make the system, while designing, robust enough with introduction of hardware security modules and similar kind of circuitries that actually has authentication and signatures, while the transmitted data, whichever is coming back, is actually first of all encrypted, and the second of all, it has its own signature, so that while verifying signatures, that's how we do it. But these are the two use cases in this short span of time I wanted to focus on, just to steer your thought process that that there exists another paradigm of cyber threats which emerge from electronic hardware and the advancement that has been happening in this area. Thank you so much, first of all, to the esteemed panel for giving me this opportunity, and to GAISA. And it is immense honor to be a part of this eminent panel. So thank you so much.
Thank
and
Pallab.
have a wonderful day.
Thank Pallab. And I